Okay, for this module of learning, we're going to be looking at the National Snow and Ice Data Center. So we're just going to put a couple of notes to ourselves in here. This is Module 1. We're going to be looking at the sea ice climatology. And the data that we're going to be looking at, data sources. Again, remember when we put things behind these pound signs here, but behind these hash marks, then this is just a comment. The R code isn't going to run. We're going to be looking at https NSIDC.org/. Okay. So this is what this looks like. This is the National Snow and Ice Data Center, and they have all kinds of data that you can look at that are global. They have frozen ground, glaciers, ice sheets, ice shells, sea ice, snow, soil moistures, all kinds of cool things that you can take a look at. When you hear anything about the cryosphere or the polar oceans, we're going to be using sea ice. We're going to go ahead and click this Explore Sea Ice Data. And the one that we're going to use is actually the first one here, called the Sea Ice Index. It gives a little explanation for what this is. It goes from 1978 to present. It's ice extent, sea ice concentration, and so you can take a look at more detail here. The Sea Ice Index provides a quick look at Arctic and Antarctic-wide changes in sea ice. Its source is for consistent, up-to-date sea ice extent, and on. It tells you a little about it. If you actually want to get the data, we click on Sea Ice Index here. It'll open up a new page. This is Sea Ice Index version 3. And again, here you can read about it again. You can read about the different satellites that they've used to collect them, and you can see the coverage. So there's the north coverage, there's the southern coverage, and then we can actually get the data by going to this file system. So if you click on it, it's going to bring you to site here in HTTPS, and you can see there's a little readme text here that is worth reading about the index itself. And then you have both north and you have south. So we're going to start by going to the north, and you have let's go ahead and look at daily and then click on data. And here we have this thing, this Sea Ice Extent Climatology. Now if you click this thing, it will download a CSV file or a comma-separated value to your computer. But the other thing you can do is if you right-click on it, you can copy this link address. I want you to do that, and we'll come over here and we'll just paste it. So we're going to use this link here to read data in. And so we're going to use a function called read.csv. Let's just take a look at that here again. Read.csv. And if we take a look at the help, this is going to read in a file. In this case, our file lives here on the internet, and we're going to add some arguments here about whether or not it has a header, separate, a quote, any of those things, and we're going to get this read directly into R right off the National Snow and Ice Data Center. Alternatively, you could download it and then read it from a place on your computer, but this makes it nice and easy to read it right from the internet. So we're going to call this CLM, Arctic Climatology. It's going to be equal to, remember this is our assignment, read.csv, and our file is going to be put in quotes, is going to literally be this whole path. Okay. This file also does have a header. So we'll put header equals true, and we're going to skip one line. Right? We're going to skip one line. So what that means is we're going to read it in, we're going to skip one line. If we read this in, boom, there it is. Here's our Arctic Clim. If you click on this, you can see what it is. Here's the day of year, the average extent, the standard deviation, and then you have the 10th, 25th, 50th, 70th, and 90th percentile. We're going to be focused mostly just on day of year. Remember, this is an average, so it goes all the way down to 366 in this case, because you have to account for leap year. If you go down, you can see, yeah, all the way down to the end. There it is, 366. here is the average extent and the standard deviation. So that now is going to be read in. We can click back over here back to our script. So that's good. Got that there. What we can do is go ahead, if we want, go ahead and take a dimensions, Arctic Clim, the dimensions. If we read the dimensions, this is 366 rows by 8 columns, and that's what we saw here, right? So there's 366 rows, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so far so good. Those are the dimensions. We can also take a look at what's called head, arc, CLM, and run this, and it will bring up the first 6 rows of this object that you made, Arc Clim. Again, this is just the first 6, but 1, 2, 3, 4, 5, 6, 7, 8 columns. Again, if we take a look at this, you can see that it's basically exactly the same, right? 1, 13.78, or 778, standard deviation is 0.407, and so on and so forth. This is the first 6. So it's an easy way to do an inspection. All right. So let's now go ahead and plot this. So we're going to use the function plot, and we need to give it our x dimension. So our x is going to be arc clim bracket 1. That's this first thing. This is day of year. So that's going to be our x dimension. And then it's going to be our y equals arc clim bracket 2. What does this notation mean? This notation means I want you to take all the rows of arc clim and just the first column. This one says take all the rows of arc clim, because there's no assignment there, and the second column. So we're going to apply all of this versus all of this, right? So that's those plots. Let's just see what that looks like a minute. We'll run that. Oh, I guess I got to actually, I misspelled something. See, that's easy to do. Let's try this again. There it is. Okay, so there's Arc Clim 2 and Arc Clim 1. So this is our day of year. So we can clean this up a little bit. I'm going to go ahead and make this a little bit larger. There, we can see a nice seasonal pattern. So let's see, what's the best way to clean this up? Let's go ahead and change the point character, PCH equals 20. That's going to make it solid points. That looks a little bit nicer. And we're also going to put a X label, and our X label in this case is going to be day of year. And our Y label is going to equal average Arctic sea ice extent. Let's go ahead and plot that. There it is. Day of year, average Arctic sea ice extent. Now we got to put a unit on that thing. So let's just maybe we'll put it in the main here. So let's just make a main title. And our main title is going to be sea ice extent, and this is in millions of square kilometers. All right, let's try that now. Good, now we got a nice title up here, a nice label, and so there it is, right? So you can see that certain days of year, right? So this is January over here. We proceed into the winter and we get a lot more sea ice, and then it starts to melt, maybe around day 100. And as we go down into the spring and into the summer, we get a minimum, and then into the fall in the northern hemisphere, we keep going back up. All right, so as far so good. Now, what if we try reading in the Antarctic file? Okay, let's give that a shot. Well, if we go back to our website, and we hit back again, all the way to this one. We can click on South, and then go to Daily, and go to Data. And here is our climatology for the South. So you can see it's got the little S up here. So that's for the Antarctic. So let's go ahead and copy this link and come over here. And we'll just, for now, we'll just store it behind a hash mark here. That's the one that we're going to need. And then all we need, we can just edit this thing. Bring this down here. And let's call this ANT. ANT. And we are now going to read in not this link, but this link instead. Let's go ahead and run that. Run. Okay, it's reading it in. Now if we go back to our environment, we can see we have something called Antarctic climatology. And there it is. There's day of year, average extent, very similar to Arctic. Same type of format, and so our plotting should actually be quite similar. So again, we can do this head just for fun, just to see, convince ourselves that it's different data. Let's just call this ANT CLM and ANT again. What's this function doing? It is acting on this object AntClim. It's giving you the dimensions, 366 rows by 8 columns. That's what we saw. And this is the head, the first 6 rows, just to see what that data looks like. There it is. That's just what we saw over in the browser over there. So to plot this, we can just copy this guy. I'm sorry, let's just copy this guy, this plot, and we just have to change this. Let's just change it to ANT, Antarctic, ANT, right? Instead of Arctic, this is Antarctic. And let's run that. Oh, well, that looks quite different. Very different. So now here we are in January, and of course in the southern hemisphere now we're coming into summer. That's summertime, and then we get kind of into the late fall, and then now we start freezing up again, and the peak of winter is now over here sometime, right? So here's July in here somewhere, and then we continue to go down, right? And so that's pretty cool. So let's see if we can put these two plots together. Let's go ahead, put a note here. How about if we just note this to ourselves? Let's just say, whoops, let's do it here. This is plotting only the Arctic sea ice extent. And that's just to remind ourselves, this is plotting only the Antarctic sea ice extent. Let's put them on the same plot. Let's put them on the same. So let's look at these two plots here a second. So here's Antarctic. What's the range here? It looks like we go from like 3 to maybe almost 20 over here. And if we go back one here, we go from like 6 to 15. So it looks like the Antarctic actually has a bigger extent. So let's now do a plot plotting both the Antarctic and Arctic sea ice extent. Well, let's see what we can do. Let's just take this plot of the Antarctic. Let's start with that one. Okay, so let's go ahead and run that again. And we get that plot all over again. And then we can take this guy, this plotting, the Arctic, and if we want to add something to the plot, we can use a different function called points. Called points instead of plot. And what points does is it adds data to an existing plot. So let's add this. Let's run it. Oh, and you can see it pop right on there. But now we have a little bit of confusion here because this axis over here says average Antarctic sea ice extent, and it's not clear from the plot which one's which. You could probably guess it because they oscillate seasonally. So let's go back over here and just call this average sea ice extent. Okay. This points command, we don't really need to have all this stuff in here because it's already going to be Right, so let's do this. This is just going to be average sea ice extent. Okay, and we need to make this a different color now to differentiate this. So let's do col equals gray. Now by default, the plot function plots things in black, but we can just add this. Okay, so now we have gray over here. And then what we need to do is just add a legend to differentiate these two things. Let's do legend. What does legend want? Legend wants our X. Where do you want the legend to be? Let's put it down here, over here. Let's put it on the bottom right. And our Y value, oh, we'll just stick it down there, yeah. And then our legend itself, what are we actually going to write? We're going to concatenate two text values together. It's going to be the Arctic and Antarctic, right? Arctic and Antarctic. And you can really set any colors you want in here. Let's do PCH equals 20. That's going to give us the point character. The line weight is going to equal 2. Right, so if we just stick this in here, they're both black. So that doesn't help us. So we need to do something a little bit different here. So we need to specify our colors. Color equals, the first one that we're plotting, the Antarctic, is black. And the second one is gray. So all this does is concatenate a vector together, right? If I just run this thing down here, it's just black and gray together. First one that we're plotting, Antarctic, is black. In fact, we can make that specific here. Let's just make a color equals black. So you can see this corresponds to the first thing you plotted. This corresponds to the second thing that you plotted, in which case is the Arctic. Right, let's try that. Okay, that's a little better, right? Wait, did we do that backwards? I think maybe we did do it backwards, because we did the Antarctic first. Okay, so that means that we need to change the order here of our label and do Arctic, then Antarctic, because that's the way we did it. We plotted the Antarctic first, so let's go ahead and run this whole thing again. There we go, right? So the Antarctic is our black one, our Arctic is our gray one, and let's add something here to the label. Let's do horizontal equals true. Now if I just add this legend on here, it's just pasting it on an existing one. If we want to get this out of the way, this old legend, we got to recreate the graph. Just take these three commands, run them again. There's the Arctic and the Antarctic, and I don't know if I like this box over here, so I'm just going to say the box type ty equals no box type, and rerun these. Okay, so that's kind of cool. So you can definitely see the seasonal climatological differences for an average year. This is day of year between these two. And you notice that they're not really equal. So there are times of the year where you actually have maximum and minimum global sea ice. And of course, one way to do that is to just make a plot of it. How about if we just plot global sea ice? And here's what we can do. We can just grab this guy. We're going to plot. If we go back to this, just make a new one. This is going to be average sea ice extent. Let's just call this average global sea ice extent. And we're plotting Antarctic Climatology 1, Antarctic Climatology 2. But of course, we can just add the Arctic climatology. Right, so we're just adding these two values together. We're adding this guy to this guy and plotting that. In fact, if I just run this command, you'll see that it just gives me one vector of those two numbers added together. That's all it is. So we can, and of course, Antarctic climatology, this is just day of year, which is the same for both of these data sets, so it should work out. So let's go ahead and run this. Cool. All right, so we have average global sea ice extent. So this is the Arctic and the Antarctic together. It has some minimum down here, and it has kind of an interesting maximum here and here too, around year 300 when there's the maximum amount of sea ice. And that has to do with the differences of where sea ice is in these two locations. So see what you can do, and we'll talk to you soon.